Right, in this session, I want us to check the concept of arithmetic sequence. So, arithmetic sequence, the formula is given by Tn is equals to A plus into n minus 1 multiplied by the difference. Okay, so Tn represents the value, okay, the term value, and then A, okay, A is the first term, and then n is the position of that value, and then D it's our common difference. Okay, so in an arithmetic sequence, this is a sequence whereby we have a common difference between any two consecutive terms. Okay, suppose you are given a pattern like this, 18, 24, 30, and then we have 30, 36. Okay, so if you're given this kind of pattern, you can see that to move from the first term to the second term, we need to add 6. And then to move from this term to this term, we must add 6. And to move from the third term to the fourth term, we must add 6. So this 6 is our common difference. So it means D in this case is 6. Okay, so now how do we get the difference? So the difference is calculated in this way. We say D is equals to T2 minus T1. So the difference is just the difference between any two consecutive terms. Okay, so if we take T2 and subtract T1, it means we're going to have 24, then minus 18, then we get 6. Similarly, for confirmation purposes, D, we know that this is T2 minus T1, and it should be equals to T3 minus T2. Okay, so to confirm that your D is really constant, you can use this formula here. This is for confirmation purposes. And also when we are dealing with simultaneous, we're going to be using this formula here. Okay, so from the pattern given there, we can find the general formula for this pattern. Okay, so already we know that the value of A from that pattern is 18, then our D is 6. Okay, so now Tn is equals to A plus into n minus 1 multiplied by our difference. Okay, so we substitute the value of A, it's 18, then plus into n minus 1, our difference is 6. Then we multiply out, we remove the bracket. Okay, so now it means we have 6n minus 6 plus 18. So now it means our Tn is equals to 6n, and then you do the maths here, and then you get positive 12. Okay, so this is the general rule for that pattern there. Okay, so to check whether this general rule works, we can try to find T1. Okay, so T1, it means where we see n, we're going to substitute 1. And then when we calculate, this is 6 plus 12, which gives us 18. And we can see that the first term here is 18. Okay, so we can look for term number 3. Okay, for term number 3, this is where when we see n, we substitute with 3. Then this is plus 12. Then it means we are having 18 plus 12. And then this gives you 30. And we can see that term number 3 here is 30. Okay, so if a question might come and then they want you to determine term number 50, it means where you see n, you just have to substitute 50. So it means T50 should be equals to where you see n, you substitute 50, and then we put 50 here, and then plus 12. Okay, then when you take your calculator, 6 multiplied by 5 it's 30, and then we also put this 0 here, then plus 12, and then we get 312. So this is just an example of how to find the general rule and how to apply it. Okay, so without any waste of time, I want us to check this example here quickly. All right, here is our example now. Given the following arithmetic sequence, you're given a pattern there which is descending. You can see that we are having 10, 7, 4, 1, and negative 302. So if you see a term like this, or a pattern shape like this, it means this value here is the last term of the sequence. Okay, so the first question says they want you to determine the value of the 21st term, which is term number 21. Okay, so remember we're dealing with an arithmetic sequence. So an arithmetic sequence, the general formula is given by a plus into n minus 1 multiplied by the difference. Okay, so in this case we must find the value of a and the value of d. So our a value, which is the first term, it's 10. Okay, so how do we find the difference? We can say d is equals to t2 minus t1. So to move from here to here, we take away 3. Then to move from this to this, we take away 3. So it means our d is negative, it's negative 3. Okay, so it means for term number 21, we're going to say our a value here, it's 10. Okay, plus into our n value, we're looking for the 21st term, then minus 1. Our difference is negative 3. Okay, so when we simplify this, it means we're going to have 10 plus into 20 minus 3. Then 20 multiplied by negative 3, it's negative 60, plus 10, it's negative 50. So the 21st term, the value for the 21st term, it's negative 50. Okay, so the second question says, how many terms are there in the sequence? Okay, so remember, we know the value of the last term. So if we know the value of the last term, we can calculate what? Its position. So remember the value, we're talking about Tn. Okay, so in this case, it means our Tn will be equals to negative 302. And then we should calculate the position for this. Okay, so for number 2, we know that Tn is equals to a plus into n minus 1. We are still in arithmetic. So our Tn value is negative 302, which is equals to our a value is 10 plus into n minus 1. Then our difference was negative 3. Then we can take this 10 to the other side, and then we will have negative 312, which is equals to n minus 1, and then multiply by minus 3. Okay, and then we divide both sides by negative 3. When we divide both sides by negative 3, okay, then we are having 104, which is equals to n minus 1. Then we take this one to the other side, so and then we are having 105 is equals to n. So it means there are 105 terms in this sequence. Okay, I hope everything is still in order and everything makes sense for now. Okay, so this is just a small application of an arithmetic sequence. Okay, so we can move to another example. Okay, so this is our example. You are given 3x plus 1, 2x, 3x minus 7, which are the first 3 terms of an arithmetic sequence. Okay, so they want you to determine the value of x. Okay, so if you are given a sequence like this, and this is an arithmetic sequence, we know that an arithmetic sequence has a common difference. Okay, so it means when we say t2 minus t1, it should be the same as t3 minus t2. Okay, so this is for simultaneous purposes or for confirmation purposes. So you can see that when we try to find the difference here, 3x plus 1, 2x, and then 3x minus 7. When we try to find the difference here, we don't find the exact value of d, but we find d in terms of variables. Okay, so in this instance, we are going to use this formula here. Okay, so we are going to say t2, which is 2x, and then we subtract t1, which is 3x plus 1. Okay, notice how I put the bracket here, because this negative should affect everything in this term. Okay, so this is equals to t3, it's 3x minus 7, okay, minus 2x. And then now we do the algebra. Okay, so it means we're going to have 2x minus 3x minus 1, and then this side we add the like terms, then we're left with x minus 7. Okay, so this side we're left with negative x minus 1, which is equals to x minus 7. Okay, I can take this x2 to the left hand side, then I will have negative x, and then I take this 1 2 to the other side, then I'm left with negative 7 plus 1. Okay, so when we add the 2, it's negative 2x, which is equals to negative 6. So it means we divide both sides by negative 2, and then x is equals to positive 3. Okay, so this is our x value. All right, so now they want you to determine the general term for the sequence. This is question number 2. So remember, this is an arithmetic sequence. So in mind, we know that Tn is equals to a plus into n minus 1 multiplied by our difference. Okay, so do we know our a value? No. Do we know our difference? No. But we know the x value to be 3. Okay, so it means we can substitute the x value here, and then to get or to obtain the numeric a value or the numeric first 3 terms. Okay, so when we substitute 3 here, it means we're going to have 3 into 3 plus 1, and then here we're having 2 into 3, and then here we're having 3 into 3 minus 7. Okay, so now in this case we multiply this is 9 plus 1, then we get 10. Okay, and then here we get 6, and then 9 minus 7, we get that this is 2. So this is the arithmetic sequence. Okay, so when we say t2 minus t, when we try to find the difference here, t2 minus t1, then we can see that we are going to have 6 minus 10, then we get negative 4. Similarly, if you can say t3 minus t2, 2 minus 6, then we get minus 4. All right, so our a value here, it's 10, then our d value, it's negative 4. So we can now find the general rule for this sequence. So it means you are having Tn is equals to our a value, which is 10, plus into n minus 1 multiplied by our difference, which is negative 4. Okay, so now we're having 10 plus, okay, this is negative 4, and then negative by negative is positive 4. Okay, so now we're having negative 4n plus 14. Okay, so this is our general rule. So to check whether this general rule correct or not, we can try to find term number 1. Then it means you're going to have negative 4 into 1 plus 10 plus 14. Okay, so this is be negative 4 plus 14, and then you get positive 10, which is our first term. Okay, so if you don't trust yourself, you can find term number 2. Then we're going to have negative 4 into 2 plus 14, and then this is 8, negative 8 plus 14. Then you notice that the difference or the sum of this is 6. So you can see that it's giving you the exact numbers or the exact terms. So this is how we answer questions like this. Okay, so we can do some couple of exercises so that you can strengthen this concept. Okay, so we can look at another example now.